Hi, in this video we begin what is known as unit circle trigonometry. Up to this point, all of our definitions have been based on a triangle, a right triangle. However, now, while we will keep some aspects of the right triangle present, our definitions will be expanded and will be based on a circle of radius 1 unit. So that's why it's called unit circle trigonometry. So unit circle simply means a radius of 1 unit. Notice we're not saying 1 centimeter, 1 meter, or whatever. It's just 1. Here we have a unit circle. We will define the angle as being between the positive x-axis and the radius. So here the terminal side is in the first quadrant, so this is the angle, and of course the terminal side could be over here, down here, or in this quadrant. In either event, the angle is read from here, and positive in this direction, so it goes around counterclockwise all the way around, always positive. Of course, you could always come the next way, but then the angle would be negative if we came around this way. So remember, positive angles then are angles measured counterclockwise, and negative angles will be angles measured clockwise. So we have this circle of radius 1 unit, and of course we have points on the circle. Quite simply, we will now define the sine and the cosine as these coordinates. The sine of this angle is the y coordinate, the x coordinate is the cosine of this angle. So this simplifies matters a lot. That's why it is used so much. Notice there is still a connection to our right triangle. If this is the angle T, the sine is opposite side divided by the radius. However, the opposite side, which is this length, is the y coordinate. You see that? This point goes x across. That's this side here, which is adjacent to T, and up y, which is this side, which is opposite T. The sine of this angle T is going to be the opposite side, which is y, the value of the y coordinate, over the hypotenuse, which happens to be the radius of the circle, which is 1. And the cosine of this angle is going to be this side, which happens to be how much it goes across, so that's the x coordinate, divided by the hypotenuse, which happens to be 1 again. So we have then that the x coordinate is the cosine of the angle, and the sine of the angle, T, is y. In this figure we have zoomed in a bit. You can see that the x coordinate is the cosine of this angle, and the y coordinate is the sine of this angle. So you should get used to this as quickly as possible. One more thing to remember here is that since the radius is 1 unit, the length of this arc is numerically equal to the angle in radians. So notice that here, if this is T, then this is T also. Only that here, this is referring to the length, and this is referring to the angle. Remember, the angle in radians is defined as the length of this arc divided by the radius. But since we have defined the radius as being 1 unit, well then, T divided by 1 is just T. So let's do some exercises now. Here we are given a unit circle, and we have a point here whose coordinates are 1/2 and √3/2. It should be easy for you to check that this point is indeed on the circle, because the square of this plus the square of this gives us 1. So what's the square of 1/2? It's 1/4. What's the square of √3/2? That's 3/4. The sum of those squares then give us 1, and of course the square root of 1 is 1. So this point is on this circle of radius 1 unit. So what's the sine of that angle? Well, the sine of T is simply √3/2. Remember, it's just simply the y coordinate of the point on unit circle. And what's the cosine of that angle? Well, 1/2. It's that simple. The x coordinate gives us the cosine, the y coordinate gives us the sine. And you can see that in the first quadrant, this agrees with what you would expect using right triangle trigonometry. So now we have an angle in the second quadrant, and we are asked to find the sine and cosine of that angle. We're given the coordinates of the corresponding point on unit circle. So again, this is trivial. The sine of T is simply going to be equal to the y coordinate here, which is √2/2. And the cosine of that angle is going to be equal to √2/2, but negative. Again, you can check that this point is indeed on this circle. And how do you check that? Well, the square of this plus the square of this has to add up to 1. We're given this identity and then asked to show that it is true. And we'll do so by showing how we obtain it. Often when we're dealing with identities, instead of the equal sign, we have 3 bars, which means then that it will be equal to 1 for all values of T. So to show how we obtain this, we'll use unit circles. So notice, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So let's place an arbitrary point somewhere on this circle right here. We could use any quadrant, but I think it's easiest to use the first quadrant. So we have our point P. The radius of this circle, of course, is 1. And these coordinates, let's just say, well, we know that the x coordinate is going to be the cosine of t, and the y coordinate is going to be the sine of t. We also know that we have a right triangle here, so let's see if I can draw this. So 1 squared is going to be equal to the square of this side, which is cosine, which is the square of the cosine. So notice that strictly speaking, we should say cosine of t squared like this, and then the sine of t, which is this side here, squared. However, it has become the convention to write this way. So of course 1 squared is 1, and the cosine squared of an angle, we don't need to use parentheses. We can simply write cosine squared this way, and this we can write as a sine squared. And so this is very, very easy to demonstrate then, right? It's just applying Pythagoras' theorem to the little triangle that we have here. Now you may be wondering about, well, what if the point were in other quadrants? It doesn't matter in which quadrant the terminal side is, because if any of these is negative, the square of a negative is still just positive. So if I had negative cosine in here, this would still be cosine squared. If I have negative sine in here, this would still be positive sine squared, because the square of a negative number is positive. Alright, so let's look at the next exercise. One point before moving to the next exercise, I forgot to write the little angle T in here. So that's the angle here. The x coordinate is the cosine of this angle, and this coordinate is the sine of this angle. Okay. We now look at this exercise. If the sine of some angle T is 3/7 and T is in the second quadrant, find the cosine of that angle. So let's first visualize this. So this is going to be the point xy, some xy, where y is 3/7. Remember, the coordinates on the unit circle give us the sine and cosine of this angle. So this is what we know. We know that this y coordinate is 3/7. We need to find x. So given that we have a little right triangle here, we can simply make use of this little fact that according to Mr. Pythagoras, the square of this side, the square of 1 is 1, is going to be equal to the sum of the squares of these two sides. And so 1 is going to be equal to x squared plus 3/7 squared. So we need a little 7 in here. 3/7 squared. Okay. And so this becomes 9 over 49. So we simply isolate x squared, and this becomes 1 minus 9 over 49, which becomes 40 over 49. That's then going to be, x is going to be plus or minus the square root of 40 over 7. That's plus or minus 2 square root of 10 over 7. So the square root of 40 is the square root of 4 times 10. The square root of 4 is 2. That's how we got this. So now we have to decide, is it plus or minus? Well, we're told it's in the second quadrant. And so since it's in the second quadrant, we know then that x has to have a negative value. For x to have a positive value, it has to be either in the first or the fourth. Notice x is positive on this side, negative over here. So the cosine of the angle then is root 2 times the square root of 10 over 7. In this case, we're given an angle in the fourth quadrant and told that its sine is 24 over 25. And then we're asked to find the sine of that angle. So once again, let's visualize this. We see that the x coordinate then is 24 over 25. These are the coordinates of this point here. The terminal side is indeed in the fourth quadrant, and then this is the angle T. Okay, so now you should be able to visualize a little right triangle here and know that if we apply Pythagoras' theorem, we get then that y squared, which is this side of the right triangle, plus x squared, which is this side, will give us then the square of the hypotenuse, and the square of 1 is 1. So y squared plus 24 over 25 quantity squared gives us 1. So a little bit of algebra here. Y squared then is going to be 1 minus 576 over 625. That's 24 squared and 25 squared. So when you do the subtraction, we get 49 over 625. Finding the square root here now is easy. This becomes plus or minus, remember that, 7 over 25. And then we have to decide if it's positive or negative. We know it's in the fourth quadrant, and so this y value obviously is negative. Notice under here the y values are negative, up here the y values are positive. So the sine of this angle then has to be minus 7 over 25. Okay, so that's it for this video. Thank you very much for your attention. Bye.